Ready?
Hey guys, here we are, just still chilling in our balloon.
Yep.
Can't seem to figure out how to get this thing down.
Really poor planning.
Yeah, so I guess we'll be up here for a while. Oh dear. All right, so since we're up here, let's just carry on with our conversation from last time.
Let's do it.
Okay, so we're going to go from gas laws, and we're going to talk about the laws in general. Okay, so this law is just the relationship between our variables that we talked about last time.
Okay.
So how the pressure, the temperature, the volume, how the amount of gas, how they all relate to each other.
Okay. Doesn't seem too bad. Nice and easy.
We're going to focus on two in particular today. Okay. So our first one is by our good old buddy Robert Boyle.
Man.
Okay.
BFFs.
Yeah. And this is a relationship between the pressure and the volume.
Okay.
Okay. And this is usually when the temperature is held constant.
Okay, so temperature is the same, so we're going to completely ignore temperature.
Exactly.
Got it.
It's not even a variable used in our equation.
Okay, so that's why we don't see T anywhere in our equation.
Correct.
Yeah.
Correct. Okay. So it is an inverse relationship. Do you have any idea what inverse means?
I think it's when one goes up, the other goes down. They go in opposite direction.
Right. Absolutely. Okay, so I'm sure you may or may not have heard about that in math class for some time or another.
You should have.
Mm-hmm. Yeah, most definitely. Okay, so as the volume increases then, our pressure would decrease.
Okay.
Okay, or as our pressure increased, our volume would decrease.
Okay, so if I'm thinking about this, if I have a container and if I push on it and decrease the volume, I'm going to increase the pressure inside of it.
Right, so like let's say you put your finger on the end of a syringe, right? When I go to start pushing that syringe down, right? So I'm increasing my pressure.
Gotcha.
But what is happening to the amount of space?
The volume is going down.
Correct. Okay.
Okay.
So that's how this
Gotcha.
law works.
Or like popping the bubble wrap, right?
Yeah.
If I decrease if I put pressure on it, I'm increasing the pressure and decreasing the volume until it pops.
Exactly. Okay, and so we can use this equation in two ways. One way is the pressure 1 times the volume 1 is equal to the pressure 2 times the volume 2. Or you could set it up as pressure 1 divided by volume 2 equals pressure 2 divided by volume 1.
Okay.
I typically just stick to the first equation. It's just easier.
All right.
Okay?
I gotcha.
Okay, so let's try one.
Okay.
All right, so here we go. It says the gas in a balloon has a volume of 4 at 100 kPa.
Nice.
All right,
okay.
so right away we know that 4 liters must be a volume because it's a measurement of a liter.
Yep, and it says a volume of.
Well, that too,
Of,
absolutely, yeah. At 100 kPa. Well, kPa was what measurement again?
Kilopascals, so it's got to be pressure.
Absolutely. So we got our V1 and our P1. Okay. The balloon is released into the atmosphere. So it's somewhere up by us.
Yeah.
Okay.
It's somewhere down there.
And the gas in it expands. So it's getting bigger.
Okay.
So it goes to a new volume of 8 liters.
All right.
We want to figure out what the pressure is on the balloon at the new volume.
Okay, so that makes sense. So I have got an initial volume, which is 4. My final volume is 8. Got initial pressure. Want to try to okay. That makes sense. I got this.
Yeah. So I filled in my little table or list, if you will, of what my volume was 1, my P1, my V2, and then I'm looking for my pressure 2. Okay. So I'll set up my equation like so.
All right.
Okay. I'll fill in my variables. 100 kPa times 4 liters equals pressure 2 times 8 liters. So now we're going to solve just like you would solve for any other algebra equation.
It's easy. Not bad.
Okay, so I take 400, with 100 times 4 is 400.
It is.
Okay, and then I'm going to divide by 8 liters, and I get 50 kPa, because we know that we have a liter on top and a liter on bottom, so those two are going to cancel out, and we're left with kPa.
Nice.
Okay?
And kPa is pressure,
and
over pressure.
It
Perfect.
works out wonderfully. Okay? So that's Boyle. Very easy. Pressure, volume, move on.
Love that law.
Okay? Next is Charles, and apparently the law jumped into the equation earlier.
Too excited.
Yep. Okay? This is by our good buddy Jacques.
Ooh, Jacques. French.
And every time I see that, I think of the little shrimp guy from Finding Nemo.
Oh, from Finding Nemo?
Yeah, right?
He cleans the tank.
Yeah.
Okay, I thought you were going to go Little Mermaid. But I didn't know if there's a French guy.
I didn't know there's.
I think they're all French in Little Mermaid.
I think they are all French in Little Mermaid. Okay, and so now this one, the last one was pressure and volume.
Okay.
So this one is temperature and volume.
So no pressure anywhere.
No pressure anywhere. Pressure held constant in this one. That K is because whenever we do with temperature, we want to be in what?
Kelvin. Okay, got to make sure we do that.
Yep.
Got it.
Okay. So this relationship is opposite of Boyle. So Boyle was inverse. One went up, the other went down.
Okay.
Okay. In this case, it's direct. So jack up the temperature, jack up the volume.
Like in a hot air balloon.
Absolutely.
All right.
Okay. So we're going to walk through our equation here. V1 times T2 now. Okay, because it is a direct relationship, those two variables are flipped, unlike the first one where it was P1, V1, P2, V2.
So in an inverse, they're together. Direct, they're separated.
You're right.
Got it.
Okay. So again, you can use that second equation that's already there for you. V1 over T1 equals V2 over T2. Again, I stick to the multiplication. It's a lot simpler to work with.
I hear you.
Okay, so we're going to practice Charles. Good
All
old Chuck, if you will.
Chucky J.
Chucky J. All right, so a gas occupies 24 liters at 75 degrees Celsius.
Okay.
What would be the volume at standard temp?
Ooh, boy.
I know.
Look at that. Wild and crazy.
So first thing that we want to do is we want to jot down all our information.
Mm-hmm.
Okay? If you notice, I already, because I'm such an awesome person,
Exactly.
converted your Celsius temperature into Kelvins for
Oh,
you.
that's so nice.
Okay, or at least reminded you to do it.
Yeah.
I didn't actually write the answer down. Okay, so you want to take 273, add that to 75.
Gotcha.
Okay.
Gotta get into Kelvin.
Right.
Otherwise it's wrong.
Correct. And then the last temperature is standard temp, which remember we talked about,
Yep.
was shorthand for just saying 0 degrees Celsius.
Yep. 0 or 273 Kelvin.
Okay. So let's set her up.
Ooh.
V1, T2. Okay, so now all you do is plug in your information. My old teacher, Mr. Sennett, Algebra 2, high school, would say, plug and chug. Well,
There you go.
Here we go.
We have plugged.
Now we are
let's chug.
okay. So we're going to multiply the 24 times 273.
Mm-hmm.
Then we're going to divide by 348.
And we
get the
And
end of the
slap.
PowerPoint.
Nice.
I don't know why 18.83 liters just did not show up for us. Okay, but so we'll nope.
Man, does not do that. Okay.
So
Just maximize that.
yep, have no idea why, but 18.83 liters is equal to your V2.
There you go. Okay.
So we did Boyle with pressure and volume, and we did Charles with
Volume and temperature.
okay. We'll do some more practice in class.
Okay.
Bye.